For this example, we're looking at a shaft which is made up of 3 segments. I'm going to call the segments 1, 2, and 3. These segments are joined by these connectors at C and D. It's also got a rigid connector there, H, on the right-hand side. What we're asked to do is to determine the internal resultant torques in the sections 1, 2, and 3. We're going to do it two ways. So this is going to be method 1. I do it 2 ways because we're going to be doing this throughout the course. And let's explore the different ways and try to figure out which one that you like the best. The method 1 is going to be by making cuts. So the first thing we're going to do is for segment 1. For segment 1, if I make a cut through here, then I've got acting on this, I've got a torque of 500 foot-pounds. I've got 250. I'm sorry, that's 350, isn't it? 350 and 600. And so I'm going to have my sign convention, I'm going to say is plus that way. And I want to find out what the resultant torque, internal resultant, is in segment 1. So as I sum my torques on segment 1, I've got minus T1, got minus 600, I've got plus 350, and minus 500. And for equilibrium, that is a 0. So T1 is equal to minus 600 plus 350 minus 500. So what that gives us is minus 1100, 350, so that's going to be a minus 750 foot-pounds. So now what I'm going to do is make a segment 2, and so I'm going to make a cut somewhere across there. So basically the same free body diagram, except I'm going to keep less of it here on the right-hand side. So 500, 350, and the torque I'm looking for here is T2. So here, when I sum my torques on this, what I get is a minus T2, a plus 350, minus 500. For equilibrium, that's a 0. So T2 is equal to 350 minus 500. So that's minus 150 foot-pounds. And then for segment 3, that's an easy one here. We basically just make a cut across there, and what we find is that the internal torque here, with the 500 there on the end, and a minus, drawing in the T3 here, when I sum my torques, I get a minus T3, minus 500. For equilibrium, that's a 0. So T3 is equal to minus 500 foot-pounds of torque. So that's the first method, making cuts, basically looking at sections. So method number 2 is taking free body diagrams of the connectors. So we have a connector there at C. We have a connector there at D. And we have a connector there at H. So I have 600 here applied by the outside. I have 350 here, and I have applied 500 here. Now I put it in the rest of it. I put in T1 and T2. I have a T2 equal and opposite. I got a T3 equal and opposite T3, like that. So if I look at connector C, when I sum my torques, what I get is minus T1 minus 600 plus T3 is a 0. If I look at connector D, when I sum the torques, I get minus T2 plus T3 plus 350. For equilibrium, that is a 0. And then for connector H, when I sum torques, I get minus T3, get minus 500. And so I work my way from right to left. I see that T3 is equal to minus 500 foot-pounds. And that agrees with what I had before. This equation here says that T2 is equal to T3 plus 350. So that's equal to minus 150 foot-pounds. And then it looks like I have registered the wrong lines here. Let me fix that up. This T2 came from this equation. From the connector C, we get that T1 is equal to T3 minus 600, so that's minus 750 foot-pounds. And sure enough, this torque is the same as above, so that is that one there. So whether you decide to make cuts, like I did here first, or look at individual free body diagrams of connectors, you're going to get the same result. Which way do you like the best? I personally like the drawing free body diagrams of the connectors because that gives me a very logical process that I follow through every time I look at a problem. But the final choice for you is really up to you. Which one will you like the best?